Lesson 8.6. I have divided Lesson 8.6 into two parts. Here we will look at part 1, which is factoring quadratic equations. We're still factoring. There's one more special quadratic equation that you will learn how to factor. It's called the perfect square trinomial. In Lesson 7.8, we learned to recognize a pattern of special products. As we went through in Lesson 8.5, the first one that we looked at was the difference of squares. Well, this one is the square of a sum and the square of a difference. Okay, let's recall the patterns that we memorized back in 7.8. We learned that when we have the square of a sum, a plus b squared, it will equal a squared plus 2 times ab plus b squared. And when you have the square of a difference, a minus b squared, the product will be a squared minus 2ab plus b squared. These products are called perfect square trinomials. A perfect square trinomial must have the following characteristics. The first term is a perfect square. The middle term is twice the product of the square roots of the first and the last terms. And the last term is a perfect square. Example number 1. X squared plus 8x plus 16. The question is this a perfect square trinomial? And if it is, how do you factor it? Well, we have to see if it follows, if it has the three characteristics of a perfect square trinomial. So the first question is the first term a perfect square? Yes, x squared is a perfect square, and its square root would be x. So keep that in mind. Let's look at the last term. Is the last term a perfect square? Positive 16 is a perfect square, and its square root would be 4. So the square root of the first term and the last term, the product of the two is 4x, and if I double that, 8x should be my middle term, and it is. So you can tell that this is a perfect square trinomial. So very simply, you follow the pattern to factor it. You would have x plus 4 squared. Okay, x squared minus 6x plus 9. The question is whether or not this is a perfect square trinomial. Does it fit the pattern? And if it does, we can use that pattern to factor it. So the first question is the first term a perfect square? The answer is yes, and its square root is x. Is the last term a perfect square? The answer is yes, and its square root is 3. And if we double the product of those two, we would get 6x. Is that our middle term? The answer is yes. So we can use the pattern to factor. So this would be x minus 3 squared. Okay, number 3, 25x squared minus 30x plus 9. Again, is this a perfect square trinomial? Does it follow that pattern? And if it does, then we can use the pattern to factor it. So again, the question is the first term a perfect square? The answer is yes, and its square root would be 5x. Is the last term a perfect square? The answer is yes. Positive 9 is a perfect square, and its square root is 3. 3 times 15 times 5x is 15x. If I were to double that, I would have 30x. Is that my middle term? The answer is yes. Therefore, to factor this, I can use the perfect square trinomial pattern. I have 5x minus 3 squared. Okay, number 4. 4y squared plus 12y plus 9. Try this one on your own. This is a perfect square trinomial. If you notice, the first term is a perfect square, and its square root is 2y. The last term is a perfect square, and its square root is 3. 2y times 3 is 6y. Doubled would be 12y, which is our middle term. So it does follow the pattern. Okay. Number 5. 9x squared minus 6x plus 4. Okay, so again, let's see if this follows the pattern of the perfect square trinomial. Is your first term a perfect square? The answer is yes, and its square root would be 3x. Is your last term a perfect square? Yes, and its square root is 2. 2 times 3x is 6x, and I'd have to double that. My middle term should be 12x. Notice that my middle term is not 12x, it's 6x or negative 6x. So this is not a perfect square trinomial, and it cannot be factored using a pattern. And now we have covered various forms of factoring, and you will be expected on each problem to look for the different methods of factoring and use them when necessary. Okay, so just as a review, let's go over all of the factoring methods that we've used. So the first thing that we learned how to do is how to factor out the greatest common factor. When every term has a factor in common, we can factor that out, and that would be the simplest way to factor a trinomial, a binomial, any kind of polynomial. Okay, now if the polynomial has 4 terms, we learned that we can factor by grouping. Factoring by grouping was another method that we learned. Then if it doesn't have 4 terms, if it is a trinomial, if it has 3 terms, a quadratic, we can check for a special quadratic pattern. For example, a difference of squares or a perfect square trinomial. Okay, so that's where you will look at it and you will learn how to recognize whether or not it fits one of those patterns that we learned. And then lastly, if none of the above work, then you will factor using product and sum method. Okay, and if product and sum does not work, then it is not factorable and you will write prime. Okay, so let's go ahead and employ all of the methods that we've learned in factoring and do some practice problems together. Number 1, 5x squared minus 80. So here we first look for a GCF, and there is a GCF of 5, a factor of 5 that we can factor out of both terms. We're left with x squared minus 16. Please note you should recognize x squared minus 16 as a difference of squares. So we'll use the pattern to factor that. So this would be x plus 4 and x minus 4. Take another look. Is there anything else that we can factor? No, there isn't. So this would be the factored form. Number 2, 9x squared minus 6x minus 35. So this is how your thinking should go. You should look at this, it's a trinomial. We should look for a GCF. There isn't any. We can't use grouping because it doesn't have 4 terms. So let's look to see if it happens to be a perfect square trinomial or if it follows a special pattern. First term is a perfect square. 9x squared is a perfect square, but our last term, negative 35, is not. So in this case, we will have to resort to using the product and sum method to factor this trinomial. Okay, because my leading coefficient is not a 1, it's a 9, I have to use the make a mistake method. So let's do that. 9x, 9x, I know that's wrong. I have an extra 9 as a factor, but I will take care of that later on. I will divide by 9 later to fix that. Now I have to find two integers whose product is equal to a times c, that is 9 times negative 35, or 315. And those same two integers have a sum of b, which is negative 6. Okay, so we need to go through a guess and test of all the numbers that multiply together to get negative 315. And when you add them together, their sum is negative 6. And so when we do that, we'll find our two integers are negative 21 and positive 15. Negative 21 plus 15. Okay, so let's go ahead and factor here. 9x minus 21, 9x plus 15. And now let's correct the mistake that we made. If you look, you cannot divide any one binomial by 9, but we can divide both of them by 3, which is the same in essence as dividing by 9. So let's go ahead and divide. This would be 3x minus 7 times 3x plus 5. I take a good look at both of those binomials. Is there anything else I can do to factor? The answer is no. And so that is the factored form. Number 4. 2x squared minus 32. Hit pause on the video. Go ahead and work this one out on your own. Okay, check your answer. It's 2 times x plus 4 times x minus 4. Number 5, on your own, 12x squared plus 5x minus 25. Go ahead and factor this trinomial, and when you're done, hit play so that you can check your answer. Okay, the answer is 3x plus 5 times 4x minus 5, and that is completely factored. Number 6, on your own. 25x squared plus 60x plus 36. Go ahead and hit pause, factor this trinomial, and then check your answer. Okay, you should have recognized that this is a perfect square trinomial, and so the factored form would be 5x plus 6 squared. Okay, number 7, try this one on your own as well. We have 4x squared plus 9x minus 16. Hit pause, factor this one, come back and check your answer. After trying to find a GCF, see if this fits a pattern, and then trying product and sum, you realize that this trinomial is a prime trinomial and it is not factorable. Okay, that will conclude the video for today. Make sure you write down any questions that you have. We will continue to work on this in class tomorrow. And be ready to practice and to apply what you've learned on this video. God bless you. Have a great night.